Hello everyone! I wanted to make this video so that we could go over some of the really big key ideas for physical and chemical change. And the first thing is, a physical change is a change where the identity of the material does not change. The shape of it might, the size of it might, sometimes you can change the color if you paint it, but the actual identity of the material does not change. A chemical change, however, is a change where the identity of the material does change. Some properties might not change, but overall, the identity does. Some properties will change, some might not. Here's some of the key vocab that I'll be referencing throughout this video. First is an atom. An atom is the smallest thing an element can be and still be that element. An atom is something that consists of one nucleus with some number of protons and neutrons and has electrons orbiting. An element is one of the building blocks of matter and is what atoms make up. All elements are found on the periodic table and they're determined based on the protons in the atom. A molecule, however, is a group of atoms bonded together. They cannot be separated unless a chemical reaction happens. They have different properties than the atoms individually. Remember, sodium, highly explosive. Chlorine is a toxic gas. React together, they're table salt, and that we're pretty familiar with. A compound, and compound is often used interchangeably with a molecule, is basically a bunch of molecules of one type together. So if you have a handful of salt, that would be your compound. All right, so we started our unit with this probe about chemical changes, and I wanted to actually address all of these points. The first one is that chemical changes are reversible. I asked you always, sometimes, or never, and the correct answer is sometimes. Some chemical changes are reversible, and some are definitely not. It does not have anything to do with whether or not the change is reversible to figure out if it's physical or chemical. I've seen a lot of people get really confused by this. They say, oh, this is reversible, it has to be physical, or this is not reversible, it has to be chemical. Neither of those are the case. Some chemical changes are reversible, some are not. Some physical changes are reversible, and some are not. A chemical change results in a new substance or substances always. That's the definition of a chemical change, that it becomes a new substance with different properties. This is always the case. If this did not happen, a chemical change did not happen. The total mass of the reactants, which you start with, is different than the total mass of the products, which you end with in a chemical change. This is never the case. Remember, our key, biggest idea from energy is energy cannot be created or destroyed. The same thing is with matter. You can't create or destroy an atom. There are some ways through radioactivity, but that's really not what we're talking about. When a chemical reaction happens, the mass of the stuff at the start is the exact same as the mass of the stuff at the end. During a chemical change, the atoms that make up the original molecules are regrouped into different molecules, always. This is very similar to the one we had a couple slides ago. It's by definition different. By definition, a chemical change happens and molecules are regrouped and their properties change. Energy is released during a chemical change sometimes. Sometimes there isn't really an exchange of energy, and sometimes energy is absorbed. You can actually have materials that have more energy in them after a chemical reaction than when it started. Think of photosynthesis. We create sugars by taking energy in from the sun. Those sugars are much higher energy than the products that we started with. And dissolving is an example of a chemical change. Never. Dissolving is a physical change, always. In order for a chemical change to happen, the properties have to change. And I know I've said this in other videos, but water and salt, we know what those taste like. Mix them together, dissolve the salt, and it's salty water. There's no property change. It's just kind of hanging out. Go ahead and look at the chemical and physical changes examples video if you want a little bit more specific. All right, I hope that covers a lot of your questions, and have a great day, everyone.